Welcome to the project demonstration of IoT battery management system along with SOC and SOH calculation. The main features of this project is as of now we are using electrical vehicles that consist of major components like batteries, and those batteries are more expensive. We need to check the battery health condition frequently so that we can get the more life from this battery pack, and so that we can drive this electrical vehicle without any disturbances. So to check the health parameters of this particular battery pack, we need to monitor the three major factors. So that is the voltage, current and temperature. From these three values we are going to estimate the life of this battery pack and SOC, that is state of charging and state of health. So in our project mainly we are monitoring the 5 parameters, that is the voltage of this battery pack and current, how much of current was connected to this battery pack, and temperature while we applying the load to this, whether the battery pack is getting heat up or not. And based on the three values we are going to calculate the SOC, state of charging, means how much of percentage is battery is charging based on the current input. For example, we are putting 12 volt 1 amp input. If the battery is charging according to the current input, then the SOC value is near to 95 to 100. And if it is not charging according to the current input, means the voltage was not increasing when we is connected to the charger, then the SOC values will be affected, and that will be comes down from 95 to below 90, 80, 70 based on the voltage increasing in this battery pack. Same as like SOH. So when we apply the load, if the battery voltage is discharged rapidly, then the SOH values will be decreased from 100 to below 70 or 60 based on the voltage dropping capacity. So these two values will define, and along with the voltage, current, temperature, it will be battery health continuously monitored. And also if is there any battery temperature is increased threshold value temperature, then this cooling fan gets switched on to make the battery pack cool down. And it has a next feature is like whenever the battery voltage is low, then the system will provide two switches to make the battery in normal charging mode and fast charging mode. So these are the features of this project. Along with it will keep on uploading the data to the ThinkSpeak. So after we log into ThinkSpeak, we can see the IoT BMS channel. There we get these parameters like voltage and current and temperature of the battery pack in SOC values and SOH values. So 5 fields continuously monitor, and this access can be done from anywhere in the world. So to execute these features, mainly we are using the components like main brain of the system is a PIC microcontroller, which is continuously monitor the input and output of the project. Input modules is like voltage sensor and current sensor, and the next temperature sensor, as we discussed the 3 parameters. And the output module is CPU fan through this transistor board, buzzer to get the audible alerts, and ESP8266 Wi-Fi module to upload the data to ThinkSpeak, and these 2 switches as an input to control these output relays for normal charging and fast charging mode. When these 2 relays get switched on, it is in fast charging mode. And 16:2 LCD screen continuously monitor these all parameters like voltage, current, temperature, SOC, SOH values. And our total system getting power supply from this 230 volts input to the power cable through this transformer, and which is used to step down the 230 volts AC to 12 volts of AC. This regulator power supply board will regulate the 12 volts AC to 12 volts of DC first stage to provide the charging voltage to this battery pack. And the next stage is regulation. So using the 7805 regulator, we'll get the 5 volts DC output, so that the system continuously getting the uninterrupted power supply to monitor these health parameters of this battery pack. So let us check with the demonstration. So before demonstration, as we are using the IoT, we need to provide the hotspot to the system. For that, go to hotspot settings of your phone and configure the hotspot name to project 7510, PROJECT 7510, without any space, without any capital letter. Password should be 123456789. AP band should be 2.4 gigahertz. After enabling the hotspots along with the data, now log into the ThinkSpeak. As you can see the old data. So if you want to get the fresh data, you can erase this data. Before erasing, took the backup. So to take the backup, data import exports and download the data, and data will be downloaded in Excel sheet format. So we can access this data from anywhere in the world. So after we download that, can open that in Excel sheet that consists of date and time. So this is the date and time at which the data got captured, date and time along with a number of entries till now how many samples got collected. 37 samples got collected. So field 1, as we discussed, voltage, current, temperature, SOC, SOH values. So after we took the backup, now go to channel settings. In that only do clear the channel. After channel got cleared, now go to private view. So private view to get the live data, channel settings to clear the channel, data import export, to download the old data, right? So now the old data got erased. Now we can on the power supply to this kit. So welcome message will be displayed, and later on, so it will connect to the Wi-Fi, and the voltage and the current, SOC, SOH values will be calculated after 10 to 15 seconds of duration. So for every 10 to 15 seconds duration, the data will be uploaded to ThinkSpeak. So this one is to get the current, means to control this electrical vehicle. We are using this DC motor as electrical vehicle. So when we on this, as we can see the current value over here, that is a 1100 milliamps of current. So we are using the 1 amp of DC motor we are using here. So when we off this, then automatically the current also will comes to 0, right? We can see the one sample got arrived. When we click on the dots, so you'll get the date and time along with the sample. So it's keep on uploading the respective data. Just keep this on, and we can check with we can isolate the voltage also. This is the voltage switch. To make the low voltage fault, we are isolating the voltage to the voltage sensor, so that it will get the 0 volts. Then the microcontroller also will get the 0 volts here, right? So you can get the low battery voltage. There we can control switches, we can control these relays. So it's faster manner and slow charging mode. Okay, when the voltage is coming to normal, right? So if the battery low, you can just keep this low voltage and leave the battery for charging at least of 15 to 20 minutes, then you will get fully charged. So you can see that the system is getting the current over here also. So again, SOC, SOH values also will be come to the picture. Same like temperature. So when we increase the temperature, when it crosses the 40 degrees centigrade, then automatically the buzzer gets switched on and fan also gets switched on. Right, you can see the temperature got raised. So in this manner, IoT presented to monitor the voltage, current, temperature, SOC, SOH values from anywhere in the world using ThinkSpeak, and locally we can control the voltage as well as current monitoring of this electrical vehicle, and temperature also, and using the cooling fan to control the temperature of this battery pack. Thank you.